Hello and welcome to Math Dailies. I'm Vivian Siteta, master in applied mathematics and passionate with it. If you would like to master college algebra, this is the place to be. This is the first part of a series, The Real Numbers, and there are more to come. Do not forget to give it a like and subscribe if you would like to receive notifications on the next to come. Mathematics deal with numbers, and the most commonly used set of numbers is the one of real numbers. R, the numbers that we use in everyday life. R is made of the natural numbers, extended by 0 to become the whole numbers in order to represent the empty. So 0, 1, 2, 3, 4, 5, the usual numbers that we know. The integers Z to include the negative numbers to distinguish quantities over 0 or below 0, like the temperature, plus 10 or minus 10. And finally, in everyday life, we don't need only whole numbers, but also the in-between, like 2.25, for example, between 2 and 3. That leads us to fractions like 1 over 4, that is the division of 1 with 4, or 0.25, that is the resulting decimal of the division, and all the decimals that are infinite but with a repeated pattern like the 12 in this example here. All these make the rational numbers Q, that are the numbers that can be written as fractions. And finally, we add the leftovers, that are all the numbers that cannot be written as fractions, the infinite decimals like square root of 3, pi, etc., that we call the irrational numbers. All the above together, they make the R set, the set of the real numbers. And let's start with the basics, with the operations for real numbers like addition, subtraction, multiplication, and division, that they all follow the rules of signs that help simplify calculations and ensure that the signs of results are accurate. Remembering them will be valuable in more advanced mathematical operations and problem solving, so pay careful attention because this is the basics of algebra. So for addition and subtraction, the rules of signs say that if we've got to add two real numbers with the same sign, we just keep the same sign and we just do addition. For example, minus 1 plus minus 3, they both are negative, we keep the same sign minus and we add 1 and 3, that we end up with minus 4. We could even omit the sign plus and just write them as is minus 1 or minus 3, and it will give the same result, minus 4. If we've got the second case with the different signs, like we have here in this example, minus 3 and plus 4, then in that case we keep the sign of the bigger one, and in that case it's the 4, and we do subtraction, so we just subtract 4 and 3, and we have the result as 1. Two other examples here, like plus with minus 2, we could just omit the sign of plus and we can just write them like that without the parentheses. That will give us 2, which is the simple also result that we would get from whole numbers. And eventually, if we've got minus 3 minus of minus 4, so the two minus that we have here, they will turn both into plus, so this will become an addition. And then we proceed with the above rules of signs as before, that will give us 1. Here are some examples to train if you would like to pause the video and check for yourself if you managed to calculate them. Proceed with multiplication and division, where we have still the rules of signs, that in this case they say that we've got the same sign, the result is a positive 1, as you can see here, and if it's a different sign, the result is a negative 1, as you can see here. So it's pretty simple. Let's see how we apply it in some examples. For example, here, this is a division. You can see that this is a fraction, but I just want to remind you that a fraction is always a division between two numbers. So either we write it like that or the classical division, then it's exactly the same thing. So we've got to divide minus 5 with 3. Then in that case, what we do, here it's a plus that it's implied for 3, so eventually they've got a different sign. We are in the second case here, so the result would be a negative 1, so it will be a negative 5 over 3, whatever, this is the result of the division. And in the second case, we've got two negative numbers, a division between two negative numbers, so this will give us a plus sign because we fall to the first case, so this will be a plus, we can even omit it, 5 over 3, and this is the result and how we proceed. Let's see some other example that it combines all the situations together. So in the first case, we've got the multiplication, and then we've got subtraction. So let's start with PEDMAS. So the priorities to the multiplication. We will do first this. We've got a multiplication between two numbers with different signs, so the result will be a negative. We do the multiplication between 5 and 3, so we have 15. And then next to it, the minus with the minus, then next to it, it will become a plus, 12. And now we have to add two numbers that they have different signs, and according to the rules of signs that we have seen in the previous slide, then we will keep the sign of the bigger one, which is the 15, so the minus from the 15, and eventually we will proceed with subtraction. So 15 minus 12, it will be 3, so the result is a minus 3, as we can see here. So let's see a slide that summarizes a little bit of all the rules of science together with some examples. And to start with, let's see the first one. So if we've got a minus and a minus, it will end up to be a positive one. So we can even omit it. The second case, that if we've got with different signs, it's exactly the same thing if it's the opposite of the signs, for example, with the numbers. In any case, the result will be a negative one, and we just do multiplication. If we've got, again, here two numbers with different signs, again, the sign of negative, and then we do the multiplication between 1 and 5. In the next example, we've got multiplication between two numbers with the same sign. This will end up to a positive, so eventually we will omit it, and we do the multiplications, it will give us the 15. The next one, we have to add two numbers with the same sign. We just keep the same sign and we just do addition. And finally, for the subtraction, let's show a little bit the theory next to it. So the subtraction eventually is just the addition of the negative number. So eventually here, 3 minus 5, it's like having 3 plus the minus 5. So addition of two numbers with different signs, that will say, according to the rules of science, we keep the sign of the largest number, so from the minus from the 5, and we do subtraction. So 5 minus 3, it will be 2. So the result, it will be a minus 2. And finally, the distributive law for subtraction, that we will see probably later on. It will be much easier to understand it. Proceed with operations between fractions. We will start with the easiest to answer with the multiplication and the division. And here it is the first example. When we want to multiply two fractions, it's pretty easy and clear cut. We multiply the top parts together and the bottom parts together, the nominators and the denominators as we call them, and we create a new fraction out of them. So 2 times 5, it will give us 10. 3 times 6, it will give us 18. And this is the result of the multiplication. In the second case, we have a division. Division is the inverse of a multiplication, so we will just transform it to a multiplication and we just inverse the second fraction. So instead of 3 over 2, we will just rewrite it as 2 over 3. And then we have a multiplication between two fractions like the previous example. So we proceed with the top parts that we multiply and the bottom parts, and eventually the result, it will be 2 over 9, as we did similarly in the previous example. Let's see some more advanced examples where we have also the signs to handle, so we should play and train a little bit more with the signs also at the same time. Here we have a multiplication between two fractions that they have the same sign, so the result, it will be a plus. And then in order to proceed with the multiplication, we just have to multiply the top parts, so 2 times 1, it will give us 2, over 3 times 2, 6. So this is the result by applying the rules of signs and the rules of fractions together. In the second example here, that we have a division. The division, we say that we will have to transform into multiplication first. So I will rewrite the first fraction. I will transform the division to multiplication, and I will just inverse the second fraction. So instead of 1 over 2, I will write it as 2 over 1. And then I will proceed. First of all, with the rules of signs. It's one negative and a positive to multiply. The result, it will be a negative 1. And eventually for the multiplication, I will have to multiply the top parts and the bottom parts. 2 times 2, it will give us 4. 3 times 1, 3. So this is the result of this example. And finally, with a little bit more complicated case, like minus 2 over 3, division, we have a division with a minus 5. We could even rewrite it as a fraction because it's exactly the same thing. I wanted to show you that either with a classical division or with the fraction, it's exactly the same thing. So it's a different notation, but for the same thing. And eventually we have handled first the division. So we'll write the first fraction that we could even put the sign in front of it instead of on top with the 2. It's exactly the same thing. So then we will transform the division to multiplication, and then we have to inverse the second part. The second part here is a -5, so it's not a fraction. How we can inverse the -5? Every integer can be considered, every real number can be considered as a fraction if we add a denominator 1 below. So eventually we can inverse it as 1 over -5, and this is a multiplication between two fractions. Excuse me, there is a 3 missing here. And there is a multiplication between two fractions that have the same sign. The result will be positive, and we multiply the top parts, it will give us 2, and the bottom parts 15, and this is the result of this last example. And let's continue now with addition and subtraction. And we have two cases here. If we've got the same denominators and if we've got different denominators. First example, we have the same denominators, the same bottoms of the fractions. In order to add them, then it's pretty easy. We just keep the same denominator, which is 4, and we just do the operation with the top part. So 3 minus 5. According to the rules of signs, we keep the sign of the bigger one, so minus, and 5 minus 3, the subtraction is 2, so minus 2 over 4. Let me remind you also that we could even simplify the fraction, which means that we will replace it with an equivalent one, but with smaller numbers, because here we can see that we can divide both the top part and the bottom part with the same number. It has to be always the same number. Eventually this can become 1 over 2, which is much easier to use in operations, as you will see later on. So it's always nice to do this simplification of fractions. Second case here with different denominators, 2 and 3. In that case, we should always try to find the least common denominator between those two numbers. If you don't remember how to find it, let me remind you that an easy trick is that we can just start with the bigger one of those two numbers. So in that case, it's 3, and we just continue to increase the multipliers of 3 until we find one that fits also the other number, which is 2 in that case. For example, 3. The 3 is not a multiplier of 2, so we continue. 2 times 3 is 6. 6 is also a multiplier of 2, so we keep 6 as a multiplier. Let's see two other examples. Check those two other examples in order to train yourself with some easy cases. Let's go back. So that means here we found that it's 6. So the target is to have a denominator 6 down here. In order to transform the 2 here to 6, we have to multiply it with 3. And the 3, in order to transform it to 6, we have to multiply it by 2. And in order to keep the same amount in the fraction without altering it, we have to do exactly the same thing on top. So we will multiply with the same number, 3, the first one, and with the same number 2, the second one. So this will end up 2, 3 up here and 2 up here. I will just keep the signs as it was, and then I will proceed with the addition as we did in the previous on top example. Here we have the same denominator, so we just leave the 6 below here, and we'll just do the operations between 3 and minus 2. They have different signs, so we keep the sign of the bigger one, which is the 3, so it will be a plus that we can even omit, and we do subtraction between 3 and 2, that will give us 1, and this is the final result that we cannot simplify further. And let's see one last example in order to be sure that you have understood carefully what it takes. So here, different is the case with the different denominators. In that case, we have to find the least common denominator between 4 and 5. We start with the bigger number between those two, which is 5. 5 is not a common multiplier for those two, so we will increase 2 times 5, it's 10. 10 is not a multiplier of 4, so we continue. 3 times 5 is 15. And so let me write it here so that you remember. No, 10 is not, then it's 15. 15 is not a multiplier of 4, so it's not 15, and then 20. 20 indeed, it's a multiplier of both, also for 4, so this is the least common denominator that we need. That means that our target is to create two new fractions with the same denominator, 20. In order to succeed, we have to multiply this with 5 and this with 4 to become 20. In order to keep the same value of each fraction, we will do the same thing on top. So here with the same number 5 and here with the same number 4. And the result is 15 up here and 8 up here. We will keep the same signs as it was before, so minus and minus. And now we have to add two fractions with the same denominator, 20. So I will keep the same denominator here, and I will do the operation between the numbers on top. Let me just see, it's minus 15 and minus 8. They've got the same sign, so I will continue according to the rule of signs, the same sign, minus, and I will proceed to addition between 15 and 8, which is 23, and this is the final result according to the rules of fractions. And let's put now all together with a little bit more complicated cases so that you can train more. So this example here, on top we have a big division, on top we have two fractions. Let's get rid first of the parentheses. We have two minuses that they will become a plus, so we'll write it as a plus, and the rest as is, so 1 over 3, so 1 over 4 here, and the same thing down here. I'm going to just rewrite them until I will proceed to the next step. Now, on top we have an addition of two fractions with different denominators, 3 and 4. I need to go over here and find the least common denominator between 3 and 4. I start with a bigger number, so the 4 is not a common multiplier. I'm gonna get the next multiplier, which is 8. 8 is not the multiplier of 3, so I will continue 12. 3 times 4 is 12. Indeed, it's the multiplier for both of them, so I'm going to keep this one. So my target is to transform those two fractions with the denominator 12. In order to succeed to that, I have to multiply this by 4. And that means also by 4 on top to keep it the same, and below here with 3 in order to keep it the same. So the result, it will become 4 here and 3 here, and I'm going to rewrite the same sign between those two. Below, it's exactly the same case. We've got two different denominators. I'm going to need to find the least common denominator between 8 and 16. The same way, I'm going to end up to find that it's 16. So eventually, my target is to have 16 down here. And here it is already the case, so this I have to rewrite it as is, but this one, in order to become 16, I need to multiply it by 2, so exactly on top I have to do the same. Here it will end up to be 14, and I'm going to rewrite the sign as is. The results. Now that I've got on top and bottom the same denominators, I can proceed with easy operations. So here it's 12, the same denominator, and I'm going to add just the top part, so this it will be a 7, and here 14 minus 3, it will be 11, and I end up to this complex fraction, as we call it, because it's actually division between two fractions. I'm going to rewrite it as that so that you can see it in a different way. So it's nothing else, this complicated thing, than a simple division between two fractions. So I'm going to just do according to the rules of fractions. I'm going to transform the division to multiplication. I'm going to just inverse the second fraction to 16 over 11, and then it's just a simple multiplication, so the top parts together, the bottom parts together, whatever they will give, and you will get the new fraction as a result. And the next case here, let's start with the top part. We have a multiplication between two fractions. It's pretty easy. We just multiply the top and the bottom part, so this will be 3 over 35. And below, because we have to add two fractions with different denominators, we need to find the least common denominator between 2 and 3. As we have seen before, this is 6, and then that means that we have to transform both to 6, and in order to do this, this has to be multiplied by 3, and this has to be multiplied by 2 on top and bottom to keep it again the same fraction. And this will give us 3 here and 2 here. And let me rewrite the sign between those two. And let's proceed. I will just keep the top part as is. And below, because we have to add two fractions with the same denominator. Now we keep the same denominator and we add the top part. So this will be 5. And eventually, like we did before, this is a complex fraction that we can rewrite like that so that you can see it easier. So it's a division between two fractions. I'm going to just change the division to multiplication. So 3 over 35 multiplication. I'm going to inverse the second part. So this will be 6 over 5. And then I'm going to just multiply the top parts and the bottom parts. And I will get the final result, which is a new fraction. Let me now introduce you to the properties of the real numbers that they will make our operations much easier and sometimes smarter. For example, the first one that we call it the commutative property, it says that the order doesn't play any role in addition and multiplication. For example, here, if we've got 5 plus 1 and 1 plus 5, they will both give us 6. So it's exactly the same thing. The same way with multiplication, 5 times 1, it's exactly the same like 1 times 5, so both they will give us 5. So the order doesn't play any difference, so feel free to change it whenever, whatever suits you best in your operations. The next one is the associative that says exactly the same thing but with more than 2. So eventually here, if we've got 2 plus 162 plus 8, instead of adding 2 and 162, we can just add the 2 with 8 that we know that it's easier, that will make 10, and then add it to 162. So eventually it's much easier, let's say, to do this operation than the other way around. So feel free to do any combination that suits your interest. And then we move on to the distributive property that says that if we've got a mix, like in this example here, of multiplication and addition, it's exactly the same thing. Instead of doing first the parentheses and then the multiplication with 2, which it would give 2 times 11, so 22 eventually. So in that case, we could do the distribution and just do the 2 times 8 first, plus the 2 times 3, so we will distribute the multiplication to each part of the parenthesis, which give us 16 and 6, and this will give us again 22, so it's exactly the same result. And the last two is how to find that in addition 0 doesn't change anything to the result, like 1 in multiplication, it still stays the same, the number, if we multiply with 1. And finally the inverse. In addition, the inverse for one number is the number with the opposite sign, that will give us 0, and in multiplication is the inverse fraction, so for every number is the 1 over the number that it will give us in multiplication 1 eventually as a result. So let's play with some examples in order to be sure that you understood those properties. For example, here, what do you think that it should be the number to add to 5 in order to get 0? I imagine that for all, it's pretty easy to tell that it's the opposite, like the minus 5 that will give us this. The same way, the minus 3 plus, I imagine you understand that it's the 3, that it will give us 0. Here, in order to multiply 3 with some number to get 1, as you can imagine, this is the inverse, as we said, according to this property here. So it will be the 1 over 3 fraction that will give us the inverse 1. And for the 2 over 3, it will be in the same way, the 3 over 2. And this is how we apply the properties of real numbers. And because in real life we need to compare quantities, we have put all the real numbers in a real number line, as we call it, like you see here, where we have in the middle the origin, which is 0, on the right positive numbers, and on the left part the negative numbers, like 1, 2, 3, 4, 5, and all the in-between, of course, numbers. Like you can see here, the pi, which is an irrational number, it's approximately 3.14, so it's a number between 3 and 4, like square root of 3, the minus 1 over 6 as a fraction, or the minus 2.75 for a decimal number between minus 3 and minus 2. And in order to compare in mathematics, we have invented those signs here. So we have the smaller, the greater, the smaller or equal, and the greater or equal. Just a tiny trick to remember which is which. Just remember that the arrow, it always shows the smaller one. For example, here we can write that the pi number, which is 3.14, to remind you, it's greater or equal of the number 3. And in order to train, you can just pause the video and just write the inequalities between those two and those two, the 3 pairs that I'm giving you as hands-on. And let's train a little bit more with inequalities to get at ease. With the first case, let's try to read also. -1 smaller than 3. Indeed, a negative is smaller than a positive number, so this is true. It's 2 smaller or equal of 2. This is true because of the equal sign here. And the third case with decimals, -2.7 smaller of -1.2. Indeed, this is true. If you try to put them in the real number line, you will see that this is much to the left than this one. And then we will continue with the double inequality that we have to read it little by little. So we will start first with the first pair. So -7/2 smaller of 7/2. Indeed, it's a negative fraction, then it is smaller from the positive one. And then let's try to see the second case, the second pair. 7/2 smaller of 7. Indeed, we don't need to use a calculator because this is 7/2 is the 7 divided by 2, so it's half of 7, let's say. So indeed, it's smaller than the full 7. So this is true because all of those inequalities are true. And finally, another double inequality. So -4 smaller of -2. Indeed, it is the case. And -2 is smaller than 0. Indeed, it is true because the -2 is to the left to the 0. And because both of the inequalities are true, all of it is true. And we finish with the last notion, which is the absolute value. That is nothing else than the distance from the origin 0. So the notation is 2 vertical bars around the number. So the absolute value of 2 is 2, which is actually the distance from the origin. In the same way, the absolute of -3 is the distance from the origin of -3 and 0, which is 3. So eventually it's always the absolute, the number without the sign. So it's always an absolute, is always a positive number. And if we want to do some examples, the absolute of 0 is 0 because the distance from 0 is 0. The absolute of 5 is 5. In the same way, the absolute of -5 is 5. So we just take out the 5 and this, the sign, and this is how we calculate the absolute. And of course, if it's in between those two other numbers like A and B here, the distance, it's always the absolute between the difference of the numbers, so 5 minus 3. So absolute of 5 minus 3, we do first the operation in between, so it's the absolute of 2, which is 2 eventually. And of course, you can imagine that if we want to calculate the opposite, the BA, it would be exactly the same. So 5 minus 3 or 3 minus 5, exactly the absolute of 2, that it will be 2. It will be exactly the same. I have put also some theory here that you don't need to think much about it for the time being, but if someone wants to dig a little bit further, I would like to provide it for you. Let's see some examples now so that you can train more with absolutes. First case here, that is quite simple. Let's calculate this absolute. We will do first the operations in the absolute. So this will give us 3 inside. So the absolute of 3 is 3. So it's as simple as that. The next case, in the same way, this will give us -3 inside the absolute, and the whole absolute, it will give us again 3 because it's always without the sign, the number. In the next example, we have a subtraction between two absolutes. Let's calculate each absolute alone first, and then we will do all of it together. So the first one, it will be a -2 here, and the second case, it will be a 2. And in order to replace the absolutes with the equivalent, so the first one, it will give us 2, the second, it will give us 2, so eventually the result, it will be a 0. The next case. Here on top we have a 4 minus 7, so it will be a minus 3, and below a minus 6. The absolute will give us 3, and below minus 6. I can just put the minus in front and then rewrite the fraction, and I could even simplify the fraction because I can see that they can both be divided with the same number 3, so that will give me 1 over 2, and this is a simplified result. And I've got 3 cases that I will do only the first one that are completely pretty advanced, and I will let you to pause the video and do the other things with pen and paper or any digital other equivalent alone at home so that you can train with them. So the first case. First, I will try to calculate the absolute. So I will rewrite everything as is, and I will just replace the absolute. Below, there is a multiplication between two numbers that are both negative, so the result it will be a positive, and I will just do the multiplication as simple as that. Here, I've got an inequality. And on the other side, I'm going to take away first the parentheses, so we'll rewrite minus 2 over 4 plus 1 over 3. And below, I've got an absolute of multiplication, so I will do first the multiplication inside. So this will be a minus 2 over 10. I'll multiply the top and the bottom, and I will continue. So let me write down here, because I've got minus 1 and minus 2, that will give me a minus 3. So eventually minus of minus 3 on top and a 6 below. And on the other side, I will have below here, let's do this, that it's pretty easy. So I will just take the absolute and we'll just leave it as is without the sign. And below, on top, I have to add two fractions that they don't have the same denominator. So I need the least common denominator between 4 and 3, and this will give me 12. So I need to transform below 12. So I need here to multiply by 3 and here by 4 in order to transform them to the same denominator. So I will have minus 6 over 12 plus 4 over 12. And let's continue. So here the two negatives will give me positive, so it will end up to be a 3 over 6. And here on this side, I will have the same denominator, minus 2 on top and 2 over 10 below. We will continue. So in the first part I have 3 over 6, and on the other side I've got minus 2 over 12 divided by 2 over 10. So you need to continue by transforming this to a multiplication, inverse the second one, and then try to do the multiplication between those two. Finally, at the end, in order to compare if this fraction, the 3 over 6, that can be simplified to 1 over 2, if it's smaller or equal to the result that you will find. I will let you to continue and finish this run, and also the other two that are left as complicated examples, in order to train as much as possible with all the things that we have seen in those slides together until now. So this is it with the real numbers. Thank you for watching. Radicals and complex numbers are coming soon. Do not forget to make a like and subscribe if you want to stay updated. Until the next one, take care.